Hey TechKnowStuds, in this video we're going to talk about congestion avoidance. Congestion is when there's so much that's happening on your network that it can't do anything else. Similar to traffic, when traffic gets really heavy and some point in time it gets so heavy that nothing is really happening. Your network can have the same thing happen to it. And there are mechanisms that help avoid that from happening. So let's talk about what we can implement on our network to create congestion avoidance. In this video, we'll talk about why congestion avoidance causes such problems on your network. Then we're going to get into RED and WRED. So let's get started. This is the network that we've been working with. And let's say that there's a lot of traffic that's happening. So what's going to happen is on R1, because this is a serial connection right here, that traffic is going to build up on R1. And there's going to be a lot of traffic that's going to be on here. And it's going to be from a lot of different devices. And maybe they're trying to reach this other network over here, and it just keeps getting stacked up more and more. Well, what happens is that we talked about on the layer 4 something called windowing. Windowing is a mechanism of TCP that allows it to recognize, hey, I'm not getting acknowledgments like I think I should. And so what I'm going to do is I'm going to cut back on how much information I'm trying to send to see if I can get information over to the other side. Which is kind of a good thing, right? We cut back on how much traffic is going through here, and because we're cutting back on the traffic, then there's less going through R1, and it relieves some of the pressure. But the problem with this is that all of the devices kind of get this message at the same time, and they all cut back at the same time. So what happens is you've got this really elevated level of traffic that's coming across, and now all the devices can't get through. Windowing happens, they cut down how much information they're sending, and so suddenly they all kind of tank. Now, part of windowing, and your traffic just really dips way down. And then what happens is all the devices say, hey, things are flowing pretty good now, so I'm going to start ramping up. And so all of those devices start ramping up again. And now you have a congested network again. And the same thing happens. And now you're getting waves of these times where network stalls out and is not flowing very well. And then times when you're really just not using your traffic or your network hardly at all. And so this is the problem with congestion on your network is as it becomes gridlock, where you have these waves of lots of traffic, too much traffic, and not enough traffic. So we want to eliminate that. So we do that in this congestion avoidance right here. Congestion avoidance will allow us to stop certain traffic. And there's a couple different mechanisms that will do this, but essentially what we're doing is we are saying that we are going to purposely drop some of the traffic to allow other traffic to communicate well, and we won't get those waves. It's still not great. Like if we're dropping traffic, that's not a good thing, but it's better than all of our traffic just tanking, and then we have extra bandwidth and creating these waves. So it's better than nothing. So congestion avoidance allows us to detect this early and then start dropping those packets before it becomes really problematic. One of the ways it does this is random early detection, or RED, R-E-D. So this random early detection will allow devices to realize when it starts stacking up, when congestion starts happening, and then be able to start dropping packets. And it does it randomly. We also have this thing called WRED, or weighted random early detection. And so It essentially is the same thing as RED. It's an extension of RED, except for what it can do is it can selectively choose which traffic it's going to drop. Now, in my last video when we talked about the DSCP fields, we talked about there's different classes, and it can selectively choose not just which class, but maybe it selects which is the lower or the higher priority drop rate and so it can selectively choose within there what it's going to eliminate. And so that is the weighted part of this. The weighted part of this is it just can get better at selecting the right type of traffic to drop, and so it's not dropping things like voice conversations. So in our model right here, it shows that we are prioritizing these voice packets here, but we're selectively dropping certain other packets within here so that way we can maximize our throughput. So there you have it. There is congestion avoidance. What it happens is there'll be these network waves that will cause havoc on your network. And so to compensate for that, we have this random early detection that detects things early and then randomly drops those packets. Or we have a weighted random early detection, which will actually put some priority on which packets it's going to drop.